Hello everyone. Today we are discussing the recap of what? Hydrogen spectrum. The revision of hydrogen spectrum. Okay. So hydrogen spectrum was explained by whom? Niels Bohr. So Niels Bohr has explained the hydrogen spectrum for the first time. Hydrogen atom is what? Single electron species. It contains only one electron. Hydrogen atom contains one electron. So he explained, Niels Bohr has explained what? The spectra of the atoms and ions having only one electron, like hydrogen atom, He plus ion, Li plus 2 ion, Be beryllium plus 3 ion, and so on. Only one electron species were explained by Niels Bohr. Okay. So now here in hydrogen spectrum, what we have discussed in previous classes. Suppose we take hydrogen atom. It is nucleus of hydrogen atom. Nucleus of hydrogen. Around this, what will be there? First orbit. It is what now? N is equal to 1. That is which shell? It is K shell. K shell or first orbit. And if you take second orbit, it will be what now here? L shell. Second orbit is what now? L shell. Okay. So second orbit is what? L shell. So this L shell has n value how much now? N value 2. And like that, if you take now infinity orbit, it is what now? N is equal to infinity. N is equal to infinity. So infinity orbit, second orbit, first orbit. It is nucleus of hydrogen atom. Now nucleus has which charge? Positive charge. If electron jumps from second orbit to first orbit, suppose electron is jumping from what? Second orbit to first orbit. So electron is coming from second orbit to first orbit. In this case, what happens? Tell me. When electron jumps from second orbit to first orbit, what happens? Amount of energy will be released. Some amount of energy is released. So this amount of energy released in the form of radiation. This energy is released in the form of what? Radiation. Okay. And now here what we have to understand is that now which line is observed here? Which line will be observed when you pass this radiation through prism? When you pass this radiation through the prism, what happens? Tell me now. We get some spectrum now. So in this spectrum, which line will be observed first? Lyman series line will be observed here. Which line will be observed here? Lyman series. In Lyman series again, which line? First line. So H alpha line of what? Lyman series. Lyman series. How you said Lyman series here? Electron is coming to first orbit. Electron is coming to first orbit means it is Lyman series. And electron is coming from second orbit to first orbit. No? Electron is coming from second and coming to first orbit. In this case, we take first line. First line is nothing but alpha line. So alpha line of Lyman series is nothing but first line. The first line of Lyman series is what now here? Alpha line, H alpha line. Okay. Suppose if electron is jumping from infinity orbit, electron is coming directly to first orbit. Suppose electron is jumping from where to where? Infinity orbit to first orbit. If electron directly jumps from infinity orbit to first orbit, suppose in this case also some amount of energy is released. This energy is called what now? Limiting line. Limiting line. So limiting line of what? Again, Lyman series only. Limiting line of Lyman series. Why it is Lyman series? Because electron is coming to first orbit. So N1 value must be taken first. Means first orbit. N1 value is 1. And limiting line. For any limiting line, N2 value will be what now? N2 value will be infinity. So N2 value of any limiting line of any series. Limiting line of Lyman series, limiting line of Balmer series, limiting line of any series will have what now? Only infinity. N2 value will be infinity. That's okay. And for Lyman series always, whether it is alpha line of Lyman series or beta line of Lyman series or infinity line of Lyman series, any line of Lyman series will have N1 value how much? 1. N2 value how much? 2. For alpha line. For limiting line, N2 value will be what now? Infinity. So here in this case, we have taken jumping of electron from infinity orbit to first orbit. That is the electronic transition from infinity orbit to first orbit. In this case, what we take now? Limiting line we take. Limiting line of what? Lyman series. This limiting line of Lyman series has N2 value infinity. Lyman series has N1 value as what? 1. So N1, N2 values we got here. Is that clear? Now, what we have to understand is that for alpha line of Lyman series and for limiting line of Lyman series, for which line the wavelength will be shortest. The wavelength is shortest and wavelength is longest. We have to identify. So one line has longest wavelength, one line has shortest wavelength. Okay, so this one we have to understand. Now, first, from diagram, we try to understand first here, theoretically. Now, here, energy gap between infinity orbit and first orbit is greater, or energy gap between first orbit and second orbit is greater. The energy gap between infinity orbit and first orbit, this E infinity, energy of infinity orbit is E infinity, and energy of first orbit is what? E1. So this gap is called what now here? E infinity minus E1. This gap will be greater, or E1, E2. This gap is greater. Actually, E infinity minus E1 value will be greater than what? E2 minus E1. Are you getting what I'm saying here? So what is greater than what here? E infinity minus E1 value is greater than what? E2 minus E1 value. The difference between energies of first and second orbits will be lesser, but the difference in energies of first orbit and infinite orbit will be greater. So if energy gap is different, if energy difference is greater, suppose if energy gap is greater, the wavelength will be shorter. Okay, we know the relation here. Energy E is equal to what now? Hc by lambda. Okay, E is equal H nu. So E is equal H nu, E is equal Hc by lambda we know. So here E is equal to what now? Hc by lambda. Here in this equation, now what we have, lambda and energy are inversely related, inversely proportional to each other. So energy of radiation is inversely proportional to the wavelength of radiation. Now here, if energy gap is greater for in limiting line, then wavelength must be shorter. Wavelength must be shorter. So shortest wavelength for what now here? Limiting line. So which line has shortest wavelength here? Limiting line has shortest wavelength. Which line has longest wavelength? The alpha line. Alpha line of any series will have longest wavelength in that series. And limiting line of any series will be having the shortest wavelength of any series. Why limiting line has shortest wavelength? The wavelength is shortest, indicating what? Energy gap is largest. Energy gap is largest, therefore the wavelength value will be shortest. In case of what? Limiting line. In numerical problems, they will not ask you, they will not say directly limiting line of Lyman series, limiting line of Balmer series. They say the line of shortest wavelength of Balmer series, they mention you. That means what here? The shortest wavelength line means what you have to recall? Limiting line we have to recall. Shortest wavelength line of Lyman series, suppose. Then which line of Lyman series we have to imagine? Limiting line of Lyman series we have to take. And for Lyman series, always N1 value how much? 1. For limiting line, always N2 value will be infinity. So that way N1 value and N2 value we can recall. Okay. And if they mention in the numerical problem like this, suppose the longest wavelength line, the line of longest wavelength in Balmer series, suppose. Then what we have to recall? Longest wavelength is nothing but first line of Balmer series. First line is what? Alpha line of Balmer series. Balmer means N1 value must be 2. And first line means what now? Electron must be coming from 3. 3 to 2 will be first line for Balmer series. 4 to 2 will be second line for Balmer series. So in this way, we have to understand what the concept here. So is the concept clear? Let's take the screenshot of this one. And now what we have understood from the above discussion, tell me now. Wavelength of alpha line, H alpha line. Wavelength of H alpha line is longest or shortest? It is longest. So it is greater than what now here? The wavelength of H infinity line. For any series. For any series of hydrogen spectrum. For any series of hydrogen spectrum, what are the series here? Different series what? Lyman, Balmer, Paschen, Brackett, Fund, and Humphrey series. So for a hydrogen spectrum, we have to recall these areas. Okay. So now what are wavelengths we understood here. And energies gaps will be greatest for what now here? Infinite line. So infinite line Infinity line has what? No greatest difference in energy. That's why the wavelength is shortest. So now tell me shortest wavelength line. So shortest wavelength line of Paschen series. Suppose in one numerical problem they mentioned this one here. Now what we have to recall? Tell me how to recall n1 value, n2 values. Now Paschen series means n1 must be what? 3 or 2? It is 3. So Lyman n1 value 1. Balmer n1 value will be 2. And n1 is 3 for Paschen. Lyman, Balmer, Paschen. So n1 value must be 3 here for Paschen series. And they mentioned here shortest wavelength line. Shortest wavelength line indicates what? Which line we have to recall? Shortest wavelength line means it must be infinite line. Infinity line. Infinity line of what? Paschen. Infinite line of Paschen. For any infinity line, what we have to recall? N2 value must be what? Infinity. N2 value must be infinity. Is the concept clear? So for shortest wavelength line means we have to recall infinite line. Infinite line means N2 value must be infinity. And Paschen series they mentioned in the problem. Suppose then N1 value should be taken as 3. Now tell me what is the formula? Rydberg's equation formula. Tell me here. Rydberg's equation is what? Nu bar that equals to 1 by lambda equals to R Z square. R into Z square. Where R is Rydberg's constant, Z is atomic number. Lambda is wavelength, nu bar is wave number. Is equal to what now here? 1 by lambda is equal to R into Z square into 1 by N1 square. 1 by N1 square minus 1 by N2 square. Is the concept clear? Now tell me here that is equal to R value how much? 109,678. 109,678 centimeter inverse. 109,678 centimeters into Z square will be what? Atomic number of hydrogen. Suppose if you take for hydrogen Z value, you take 1 square. Z square will be 1 square. So for hydrogen we are taking. For which element we are taking here? For hydrogen. For hydrogen atomic number is Z value 1. So 1 square I'm taking here. Into 1 by, in this problem, what is N1 value? 3. So 1 by N1 square means 1 by 3 square minus, here infinity is what here? N2 value. So 1 by N2 square means 1 by infinity square. Here 1 by infinity square value will be 0. This value will be 0. So 1 by infinity square is what? 0. So 1 by 3 square here. So 1 by 9 minus 0. So 1 by 9 into R. So here anyhow 1 square is 1. So like this we have to substitute what now? The values given. Is that clear now? So it's about what now here? The concept of calculation of wavelength and nu bar. This equation is called Rydberg's equation. Rydberg's equation. So calculation of lambda and nu bar. And after calculation of lambda and nu bar, we can also calculate energy and frequency. Na? Okay. Once take the screenshot of this now, we'll go to next page. Yeah, now check it here. Suppose I'm taking here E is equal to h nu, which is called what now here? Planck's equation. Max Planck equation. So Max Planck's equation is what? E is equal to h nu. Here 1 photon means 1 h nu. If it is n number of photons, n into h nu. So here n into h nu is what? N photons. 1 into h nu for 1 photon. E is equal to h nu here. Okay. Now here h into c by lambda. Why here? Here in this case nu is equal to what? C by lambda. We know that c is equal to mu lambda. C is equal to nu lambda. When c is equal to nu lambda, nu is equal to what? C by lambda. In place of nu, what we can write? Frequency is equal to velocity of light by wavelength. So in place of nu, what we can write here? In place of nu, c by lambda. So hc by lambda. So E is equal to hc by lambda. That equals to hc into nu bar. Okay. Since 1 by lambda is equal to what now? Nu bar. 1 by lambda is equal to nu bar. 1 by lambda is what here? Inverse of wavelength is nothing but wave number. Wave number is equal to inverse of wavelength. So 1 by lambda is equal to nu bar. Therefore, we have written hc into 1 by lambda. Hc into nu bar. So in this way, we can take what now here, any one of these here. Suppose after calculation of lambda, after calculation of lambda, energy we can calculate now. Energy is equal to hc by lambda. Energy is equal to hc nu bar. Any formula we can use here. Any formula can be used. E is equal to h nu, or E is equal to hc by lambda, or E is equal to hc nu bar. Any formula can be used. Okay. Suppose if you want to calculate energy when lambda is known, or when if you want to calculate what your frequency, we can use what now, E is equal to h nu. Okay, or E is equal what now here, hc by lambda, hc by lambda. So when lambda is calculated, we can calculate what now, energy. Okay, so like this we have to use what now here, the formula of what, Planck's equation. Okay, different forms of Planck's equation on this here. Is that concept clear? Yeah. Next, suppose they have given like this here, longest wavelength, longest wavelength line of, longest wavelength line of Lyman series. Lyman series, they mentioned in the problem. Now Lyman series means what, we have to take n1 value, n1 is equal to 1. And now here, longest wavelength line they mentioned here, longest wavelength line. Longest wavelength line means what we have to imagine, infinity line or first line, alpha line. The first line has longest wavelength. So now first line, which is also called what, alpha line, alpha line of what, first line of Lyman series. First line of what now, Lyman series we have taken. Now first line means what will be the n2 value here, n2 value what should be taken for the first line of Lyman series. For the first line, n2 should be taken 2, because n1 is 1 here, electron must come to first orbit. Okay, electron must come to first orbit. When electron comes from second orbit to first orbit, it will be called first line. When electron comes from third orbit to first orbit, it is called second line of Lyman series. So here, longest wavelength they mention. Longest wavelength means what now here, first line we have to imagine. That is alpha line. First line means n2 value should be taken 2 for Lyman series. Okay, n1 value, n2 value we understood here. Sometimes instead of longest wavelength line, they mention, okay, smallest energy line, the line with the smallest energy, the least energy line. Least energy line means what now again, first line, because the energy and wavelength both are inversely proportional. When they mention longest wavelength, we have to imagine what now, least energy. So longest wavelength meaning what here, least energy we have taken. Okay, in some problems they mention longest wavelength, in some problems they mention longest wavelength, in some problems instead of wavelength they mention least energy line. Least energy line also what, again first line. So least energy line or longest wavelength line we have to imagine. Is that clear, ma? So in this way, what we have to understand now, first line of alpha line of Lyman series means n2 value we have to take, and Lyman series means we have to take n1 value 1. Again, tell me now, nu bar is equal to 1 by lambda is equal to r into z square is 1 square for hydrogen, r into z square into 1 by n1, how much here, 1, n1 1 square minus 1 by n2 is what now, 2 square, 1 by n2 square. So like this we can calculate what now, nu bar. Now nu bar will be obtained in centimeter inverse if r value is taken centimeter inverse. If r value is taken in meter inverse, nu bar will be in meter inverse. That way we have to understand here. So nu bar is equal to 1 by lambda is equal to r into z square into 1 by n1 square minus 1 by n2 square. This is what now Rydberg's equation. So like this, n1 value, n2 values we have to understand without any confusion. This is very important part of hydrogen spectrum. Is that clear, ma? Let's take it first. Take the screenshot. Yeah. So now next thing what we have to understand is that here what we have understood here, E is equal h nu, or E is equal to hc by lambda. E is equal to hc by lambda, or E is equal to hc mu bar. From all these here, from all these things, what we have to understand is that E is directly proportional to frequency. E is directly proportional to nu bar. And E is inversely proportional to wavelength. Inversely proportional to what? Wavelength. So these areas we have to clearly understand. Now in the problem, suppose here, tell me now, highest energy line, highest energy line of Balmer series. Highest energy line of Balmer series is equal to, so highest energy is equal to what now here? Highest frequency na? Highest energy line means what? Highest frequency line. So the line with highest frequency, highest energy, both will be same na? So now here what we can take now? Highest frequency line. Highest frequency line of Balmer series. Highest frequency line of what now? Balmer series. We can take. Okay, and also we can mention the same thing. What we can mention? Highest frequency line or highest wave number line. What we can say? Highest wave number line of Balmer series. The same thing again. When energy is highest, frequency is highest, and wave number also highest. And the same line, how to say now? Shortest wavelength. Shortest wavelength line. Shortest wavelength line of Balmer series. All are same now here. Highest energy line or highest frequency line. Otherwise, highest wave number line or shortest wavelength line. All these are what now here related to what? Infinity line. That is equal to what now here? That equals to, in all these cases, what we have taken now? Tell me now. Now infinity line or first line? Tell me. Infinity line. Infinity line of Balmer series. So infinity line of Balmer series is nothing but highest energy line of Balmer series. That is highest frequency line. That is highest wave number line or shortest wavelength line. Shortest wavelength line. So like this, indirectly they will be giving. They will not give directly infinity line. They will say the line of highest energy. Otherwise, the line of shortest wavelength. So mostly they mention wavelength and energy. These two areas we should not confuse. From this we have to recall what now N1 value and N2 value. Now tell me here for this infinite line. For infinite line always N2 value must be what? Always for infinite line N2 value is constant. That is infinite. And for Balmer line, for Balmer series, for any line of Balmer series, N1 must be 2. N1 must be 2. In this example here, electron jumped from which orbit to which orbit? From infinite orbit to second orbit. The electron has jumped. The electron has undergone transition from infinity orbit to second orbit. So this area we should not confuse. Okay. After calculation of, after getting the idea of N1 value and N2 value, we can calculate what? Wavelength or nu bar. Nu bar is what now here? Nu bar is called wavelength. Is the concept clear now? So these are all things we have to understand very with concentration, without any confusion. More you read, more you get the concept thoroughly. Okay, I have sent you the material, OP tandem material. You have to go through thoroughly that. Take the screenshot of this if you need. Yeah. Next, lastly, what we have to understand now. Now, previously, what we have taken, longest. Highest energy we have taken. Now we take least energy. Suppose I am taking here least energy line. Line means spectral line here of Lyman series. Lyman series. Okay. And now tell me here least energy. Least energy line means what? Tell me. Least energy means first line or infinite line? It is first line. That is what now least energy line means what now here? first line. First line means what now? Alpha line. Alpha line of what? Lyman series. Okay, Lyman series. Next thing, the same thing. Here, least energy means the wavelength should be what? Longest. So longest wavelength. So longest wavelength line of what? Lyman series. Longest wavelength line of Lyman series or first line of Lyman series. Now here, whenever Lyman series is mentioned, N1 must be what? 1. N1 value must be 1 because Lyman series, any line of Lyman series, N1 value will be 1. Now here we have to understand first line of Lyman series. First line of Lyman series means N1 value of Lyman series is 1. First line means electron must be coming from second orbit. The electron must be coming from where? Second orbit. So N2 value should be 2. First line of Lyman series means electron must be coming from second orbit to first orbit. So N2 value should be taken what? 2. So now what is the formula? Nu bar that equals to 1 by lambda that equals to R into Z square into 1 by N1 square what here? 1 square minus 1 by N2 square is what? 2 square.